It is a solenoid. It can be defined as a coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. The solenoid is connected to battery and a switch. When switch is closed, current flows from positive terminal to negative terminal. In solenoid, we see the direction of the magnetic field according to right and thumb rule. If direction of thumb shows direction of current, then other fingers shows the direction of the magnetic field. The other curled fingers shows clockwise direction, so the magnetic field direction is also clockwise. The current flows continuously to the other terminal of the first loop. Here also we see the direction of the magnetic field according to right and thumb rule. At this point, the magnetic field direction is anti-clockwise direction. In this way, magnetic field lines are produced when current flows from one terminal to other terminal of the solenoid. So at each point, magnetic field lines are produced. So the overall magnetic field produced will be like this. So in this experiment, inside the solenoid, the magnetic field lines produced are parallel and equal, and that is magnetic field is equal. So when current flows into the solenoid side will be south pole and the other side will be north pole. Here the direction of the current is changed, that is current flows from right side to left side. According to right hand thumb rule, the direction of the magnetic field is anti-clockwise direction. Here you can see the direction of magnetic field. Next, the current flows to the opposite turn of the coil. Here we use again right hand thumb rule to find out the direction of the magnetic field. So according to right hand thumb rule, the direction of the magnetic field is clockwise direction. Inside the solenoid, the direction of the magnetic field is from right to left. Here also, as I said previously, the direction of the current into the solenoid, when enter into the solenoid, side will be south pole and other side will be north pole. So we conclude a strong magnetic field is produced inside the solenoid when current flows into the solenoid. That magnetic field is parallel and uniform. So the magnetic field is produced inside a solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside the coil. That type of magnet is known as electromagnet.